what I wanted to do, and some of you may have already heard this story, is to go over some, I think, probably the most elegant science, and this wasn't done by me, it was done by Lou Stout, when it comes down to really understanding where BCR signaling is happening and where a drug like ibrutinib can be specifically useful. And that is for the ABC subtype of large cell lymphoma. We really have reached a point where we have to understand that large cell is simply a histological term, and that it does not define a disease. It defines a spectrum of diseases. And it really took gene expression profiling from the early 2000s to really begin to understand the various subtypes of large cell. These different subtypes are as different from one another as they are from Hodgkin's. And so we really need to move beyond this idea that all large cells are the same and therefore they're all going to be treated the same way. And of course, this is showing the now well-known microarray showing that large cell can be divided into three major groups. There are more: the activated B cell type, germinal center type, and the primary mediastinal type. And these correspond to their cells of origin. This coming from a thymic-derived B cell, this coming from a B cell that's still within the germinal center, and this coming from a post-germinal center cell. And we know clinically now that those patients that have the ABC compared to the germinal center type have a worse outcome with standard R-CHOP therapy. And so what is ABC? ABC is a post-germinal center tumor cell that has undergone differentiation arrest between the germinal center and becoming a plasma cell. So one of the critical questions that Lou Stout's group asked was, what can we say about this from a molecular point of view? And what he showed early on was that a critical series of genes that defined ABC are those associated with the NF-kappa B transcription factor. And you can see here that this stimulates a whole host of genes that are generally relatively low within the germinal center, normal germinal center B cells. We also know that NF-kappa B is in fact a normal transcription factor turned on within post-germinal center B cells as they migrate from the germinal center to eventually being a plasma cell. So the question arises as to why do you see activation of NF-kappa B within a ABC large cell? And that really is where our story starts, which really starts with trying to understand the role of BCR signaling. And this is actually showing the BCR receptor, which when it engages an antigen, activates 4 different major pathways. And over here, of course, is the NF-kappa B pathway where I've already shown you that we see those genes being upregulated within the ABC subtype. Another critical pathway that I'm not going to be going over, but you're hearing a lot about, is that downstream of the PI3 kinase delta isoform where you see activation of AKT-mTOR. Now, the question that Lou Stout's group was really faced with is that if, in fact, NF-kappa B is turned on, which, in fact, they did show, and that BCR signaling activates it, why do you have this turned on within a ABC large cell? So this is where he went up the pathway over the many different protein kinases and serially went through them and did full sequencing on them. And what he found was that, in fact, there was a activating mutation within the coil domain of CARD11 in about 10% of ABCs. And this, in fact, is able to constitutively turn on NF-kappa B. But what was even more striking with regard to the story we have at hand is that around 20% or so also have not activating but enhancing mutations within the ITAM of the CD79B of the BCR receptor. Now, if you look to see what the frequency of these are within the ABC and germinal center, if in fact they are oncogenic events, you would expect them to be differentially found in ABC, and that is in fact what they actually found. Now, there is another pathway that I think you've heard a little bit about from Steve Treon, is the so-called MIGHTY88, and that we now know that MIGHTY88 is frequently a site of mutations, around 29% of ABC large cells, and as Steve showed elegantly, in over 90% of Waldenstroms, which is another post-germinal center tumor. And MIGHTY88, these actually lead to a activating mutation that actually activates NF-kappa B. And in fact, we now are beginning to show that there appears to be cross-interaction between the MIGHTY88 TLR pathways and the BCR signaling. And so, what does the overlap of these mutants look like? If you look at ABC, you actually find that around 23% of them have mutants, mostly within the CD79B, occasionally A, and about 29% have MIGHTY88, but you see a subset that have both. And so these appear to be mutations that can cooperate with one another, but how this actually is relevant clinically was unknown. And so we were interested, and we collaborated with Pharmacyclics around 4 to 5 years ago when they first started their phase 1, because their drug, ibrutinib, in fact blocked Bruton tyrosine kinase, and therefore would putatively block the signaling down this cascade. And of course, you've already heard about this drug. It's very potent, and it almost completely shuts off BTK during the entire period of the dosing. And it was shown by Lustau's group that if you look at ibrutinib within ABC lines, that it was very toxic. That if you looked at it within germinal center lines, it wasn't. And as you might expect with the CARD11, which is downstream, it was not toxic to the CARD11, which is shown here. So this really formed the science behind doing a study asking the scientific question, number one, does ibrutinib have preferential activity within ABC versus germinal center? And number two, to try to understand, at least on a hypothesis-generating basis, how the various mutants that are seen may relate to the response rate. So we did a clinical trial. These are relapsed refractory large cells. We took all comers. We looked at outcome. And then we went ahead and analyzed them using gene expression profiling by whether or not they're ABC, germinal center, et cetera, and asked the scientific question about whether or not any activity we might see was seen in one group or the other. We also did Sanger sequencing to look at the various mutant forms. And so the clinical trial enrolled 70 cases, and what turned out was that 29 of them were ABC by gene expression, 20 were germinal center, 16 were unclassified, meaning that the gene expression actually statistically classifies. And anytime you do gene expression, there's always a group that does not specifically and rigorously fall into one group or the other. This group cannot be discerned by the HANS, and this is one of the problems using HANS as your final thing. And then 5 we didn't know because there was not enough RNA. And these groups were very, very well balanced. Refractory disease was similar in both. The amount of prior therapy similar, age, etc. So ABC, GCB, extremely well balance bad actors. So what did we see showing the waterfall plot? You can see that there was clinical activity across most cases. And as you can see in blue here, ABC was where most of this clinical activity lay. And if we look at the activity defined by at least PR, you can see that 41% of the ABCs had at least a PR, whereas only 1 out of 20 of the germinal centers had this. And we also found that when we looked at OS, that there was a difference in OS with, in fact, the ABC groups having a better OS than the germinal center. And what I can tell you is that we have looked retrospectively at the outcome of ABC and GCB relapse cases, and actually they both have very similar OS. There's no difference. So this is probably being driven by the fact that these cases are being actively treated by this drug. So the question we also wanted to ask was whether or not we could generate any hypotheses with regard to the specific mutants. And so if we just looked at the subset of patients that had CD79B alone mutant, the response rate was 71%. But we also found that among those cases that were wild type for 79B and also MIT88 and CARD11, 34%. What does this tell us? This tells us that it is possible that in fact there is an intrinsic antigen that is in fact driving these tumors, and they don't have to have this enhancing mutation within the BCR. If you saw cases that were both B79B and MIT88 positive, again, the activity was very similar to that of having CD79B alone, making us think that in these cases you probably have some these cases are probably still being possibly largely driven by the BCR because it is blocked at least clinically by this agent. However, if you look at those cases that only had a mutation of MIT88 and had wild type of the BCR, the activity was 0. And what this really raises is the idea is that there is a smaller subset of cases that are completely dependent on the MIT88 pathway, and that this is probably a different pathway of pathogenesis leading to ABC large cell. And as you would expect, those cases that had activating mutants within CARD11, there was no activity. So what can we say? Well, ibrutinib was preferentially active in ABC, that we already went over this, and that we already went over this. So I think this is a very this is all very elegant work, and it really was all based on work that Lou Stout did. And so as a result of this clinical trial, there's now the multinational Phoenix trial that Janssen is running, where it's R-CHOP plus or minus ibrutinib in non-germinal center large cells, and there'll be a secondary analysis where the outcome will be analyzed specifically by assignment on a expression platform for ABC versus germinal center. Thank you very much.